What is up, YouTube? Adam here. Today we're going to be going over the doubly linked list. And so if you haven't checked out my video on the singly linked list, go ahead and check that out and then come back here. We're just going to take the singly linked list class that we wrote and we're going to rewrite it as a doubly linked list. So there's a lot of foundational concepts covered in the singly linked list video, and I'd hate for you to miss out. So for this video, we're just going to copy singly linked list.py to a doubly linked list. And then we're going to change it around to make it match all our needs. So in the previous video, talked about how singly linked lists, you need to be able to add, remove, sometimes append, and traverse the singly linked list. And so we implemented all those features here. So what we're going to do is blast through the modifications because conceptually they're really similar. So we're just going to blast through the concepts and we'll start now. So I'm using Vim and I'll be down here to do my find and replace. But I'm just going to find and replace every occurrence of S list with D list. And then I'll put global, and I can put C for confirmation to check each one. So I'm going to change that one, and I'm going to change that one. So we need to do the same thing for the lowercase. Change that one, all our mains. Okay, so now if we run it, we see it has the exact same behavior that the singly linked list has. And we're going to replicate this behavior now with a doubly linked list. The first thing you're going to want to do to augment your singly linked list class into a doubly linked list class is you're going to want to set data to be none as a default parameter. This means you don't have to declare data for the node when you're creating one. And we need a previous pointer, so we'll say prev equals none, initializing it just like we did the next pointer, and we'll throw in self.prev equals prev. Okay, so another big difference between a singly linked list and a doubly linked list is a doubly linked list has a head and a tail node. So we say self.tail equals none. But here's another difference from a singly linked list. We're going to go ahead and initialize our head and tail nodes to be empty nodes. That is, they contain none for the data. So the next step before you do anything else is you need to point the head pointer's next pointer to tail and the tail's previous pointer to head. So programmatically that looks like this: self.head.next equals self.tail, and self.tail.prev equals self.head. So to kind of draw out what this is looking like, we have our head node and it's interconnected with a tail node. So anytime we do an insertion, we're going to be sliding the values in between. Again, this makes a lot more sense if you checked out the singly linked list video. Another thing we can do is we can write some helper functions that help us add and append to the doubly linked list. So the first one we'll create is define, and we'll just say link. And because it is a class method, it'll take self, and the parameters for our function will be the previous node, the current node, and the next node. So anytime we link nodes, we're essentially sandwiching them in between two nodes around it. So the previous node will say previous.next equals current. We'll say current.previous equals previous. And then we need to link our next node. So we'll say current.next equals next, and next.previous equals current. So just like we created a link function, we'll create an unlink. And we can say self, previous again, current again, and next again. And if you remember from the singly linked list video, we can let Python handle the garbage collection for us and just slide the previous pointer over to the next. And we need to go the other way. We need to slide the next previous pointer to previous. So now nothing is pointing at cur. We can just say delete cur to mark it for garbage collection, or we can just let Python handle the garbage collection for us. So with the augmentation of the node class to contain a previous pointer and these two helper functions, adding and appending becomes really easy. To add, we want to sandwich a node in, so we say self.link, and we're sandwiching it between self.head and then our node we're creating and self.head.next. So again, this is similar to Python's insert 0 method for arrays. So now let's look at what append would look like. We would say self.link, self.tail.previous, the new node we're creating, and self.tail. And that's it. And if you look at add and append, really the only difference is where you're sandwiching the node. So now let's talk about how to remove from our doubly linked list. Removing from a doubly linked list is considerably easier than removing from a singly linked list. First, we have to iterate through the nodes in our doubly linked list. And so we could say for node in self, if node.data equals data marked for removal, then we say self.unlink, and we'll let the previous node be node.prev, the current node be the node, and the next node be node.next. So once we've removed it, we'll just go ahead and preemptively return because we don't want to do any more processing. But there's a problem with this code, and that's the iterator method has not been updated to reflect how a doubly linked list works. So we're essentially keeping the head and tail nodes as sentinel nodes because they don't contain anything. So we don't want to set our pointer to this sentinel node because we know it doesn't contain anything. So we say self.head.next to get the first valid entry in the doubly linked list. Our while loop, we need to compare on whether or not the pointer is pointing to self.tail. And other than that, it should work exactly the same. And our str method will continue to work because our iter method is now updated. You can really see how handy this iter method is. We're utilizing it in two separate functions, and it's really simplifying our code base. So with the changes in place, we'll write and quit, and we'll run the doubly linked list program, and it works exactly as expected.